How to create and manage a non-fungible Algorand standard asset from the command line. Using goal. This video is divided into two parts. Firstly, you will learn the meaning of Algorand. Standard asset properties such as total supply, decimals, unit name, etc. We will also write down the Genesis transaction containing all the properties that best fit our non-fungible Algorand. In the second phase, you will understand the role of management addresses like the freeze address or the clawback address, learning how to configure your asset management scheme. To follow this tutorial effectively, you will need the following. 1. Run a node. 2. Algorand CLI. To set up a node, follow the link in the description. The aim of this tutorial is understanding Algorand standard asset properties and getting familiar both with their creation process and management configuration from the CLI using the goal utility. To follow, taking a real use case may help us to better understand how to choose ARSA properties that best fit our needs. So let us assume someone assigned us the following requirement to create two non-fungible tokens representing the digitalization of delicious typical foods from Puglia in Brazil, namely a panzerotto and a coccinha. We will go through each step together to set up the properties of the required non-fungible ARSAs. By completing this tutorial, you will be able to create a unique digital representation of a panzerotto or a coccinha, whatever you like the most, and any other non-fungible ARSA you want. Algorand standard assets are shaped by different properties that can make them suitable for different use cases. Defining these properties allows us to decide, for example, if the asset will be scarce or not, divisible into submultiples, and so on. First thing to do when you don't know how to proceed in the CLI, ask for help. Since we want to create an asset, we should ask for help on the specific goal asset command by typing the following command. You should see an output that looks like this. We will focus on the goal asset create command, so type the following command in the command line. You should see an output that looks like this. These two requests for help are meant to encourage you to use the help flag to search for the answers you need. For the purpose of this tutorial, we will focus on the flags strictly related to shaping the Algorand standard asset. Some flags are related to general transactions properties, like first valid, last valid, fee. We are not going to dive deep into these, but you may look at the Algorand developer documents linked below to your understanding. Algorand standard asset properties. Name string. The flag name, assigned as a string enclosed within double quotes, identifies the complete name of the ARSA. Asset name. Strings may contain spaces or symbols. We will choose between panzerotto or coccinha. Unit name. Other than by its name, an Algorand standard asset can be recognized by its unit name. So we choose the following symbolic abbreviations. Decimals. This flag determines whether the asset is divisible or not. It deserves some attention. Just as read in the help section, if set to 0, the asset is not divisible beyond its base unit. If set to 1, the base asset unit is tenths. If 2, the base asset unit is hundredths, and so on. If the ARSA you intend to create is supposed to be divisible up to 0.0001, that is, 4 decimal places, you will need to assign 4 as the value of this flag. In order for panzerotto or coccinha to be non-fungible, they must not be divisible and are unique. The uniqueness property will be clarified later. So, to be non-divisible in subparts, we will set decimal to 0. Point to note. Maximum decimals cannot exceed 19. Total. With this flag we determine the total supply of an ARSA. Note. The value you pass to the total flag is intended as the total amount of the minimum unit of the ARSA. Tip. If you want to create an ARSA with decimals d and a total integer supply s, you have to assign to total flag the value of s multiply by 10 exponential d. Example. Suppose you want to create an ARSA with 2 decimals and a total supply of 500, so we will set total to 50,000, which generates 500 ARSA. The non-fungibility requirement of the asset Panzerato and Coccinha means they are not only indivisible and must not be unique, so we set total to 1. Asset URL. This string flag gives us the possibility to register a URL among ARSAs. Properties are an Algorand blockchain, giving to its owners some additional information about the asset. We state that the official Panzerato and Coccinha ARSA will carry their Wikipedia page into the URL as follows. Creator. The string assigned to the creator flag specifies the public address of the asset creator account. In the genesis of the ARSA, the creator address will be assigned by default to all the ARSA management addresses too, as we are going to analyze later. While the management addresses could be changed, the creator address represents an immutable property of the asset. Set it as the public address of an account you own. Now, we are ready for asset create transaction. Write down 2 different asset creation transactions. That of Panzerato and for Coccinha. All required flags have been determined in the previous steps. The only flags you need to complete on your own are these. Like any other transaction on Algorand, the asset create may contain a note that will be associated with the transaction and registered forever on the blockchain. A note could be useful for different purposes and must be assigned to the note flag as a string within a double quotes. We will use it to personalize the genesis transaction of this tutorial. Once we have understood the meaning of the flags that shape the Algorand standard asset, all we have to do is group this information into an asset create transaction. Panzerato asset create transaction. Choose either of the assets and assemble its transaction fields in the command line, then enter to push the asset creation transaction to the mainnet. Once the block containing the genesis transaction of the ARSA has been added to the blockchain, the asset comes to life, returning the genesis transaction ID and its asset ID. Now you can find your ARSA among the Algorand standard assets list instead on a block explorer. Asset ID. If you are familiar with database architectures, you'd know that the record's unique identity in a database is ensured by a primary key that is immutable and different with respect to all the others. Similarly, the unique identity of each ARSA is ensured by its asset ID. In principle, someone else can create an asset exactly with the same asset name and unit name that already exist on the blockchain, namely another Panzerato or Coccinha. What really differentiates your Panzerato from the one created by somebody else is the asset ID. Here's a tip. To refer exactly to your Panzerato, not any Panzerato someone else has created, it is necessary to specifically refer to the ARSA Panzerato by its unique asset ID. Asset ID PNZRT. This concept of an asset ID is very crucial to understand which assets are fungible or non-fungible. ARSA management configuration. Now that our ARSA is living on the blockchain, we will analyze how to manage it through its management addresses. To do this, we will use the command goal asset config. Once again, we will look at command flags strictly related to the configuration process. There are several ways to refer to a specific ARSA. For example, with a combination of the asset unit name, the asset ID, and the creator. In order to refer exactly to one specific ARSA, the goal asset config command requires values for the following flags. So, we will refer to the specific asset either with creator tag or asset ID tag. Managing an ARSA. The manager address, also known as manager key, is the public address that has the power to change the ARSA configuration, namely the one in charge of its management. By default, the manager address coincides with the creator address, but it can be changed. The manager address has the power to assign the following mutable addresses: clawback, freezer, manager, and reserve addresses. To start with the reserve address. This is an account's address which stores the amount of ARSA that has not yet been minted. The reserve address can be considered a logical construct that helps distinguish between circulating supply and supply to be minted. If the reserve address is different from the creator address, the creator should issue a transaction to move all funds to the new reserve address. Only when a certain quantity of ARSA leaves this reserve address is it considered minted and made available for the rest of the world. The reserve address can be replaced with an empty string so that the total supply is considered minted by the hands of its creator. Freeze address. This is the address of the account that has the power to prevent someone else from trading this ARSA. There could be classes of ARSAs that need this kind of management in order to be compliant with some policy or regulatory requirements. The freeze address can be replaced with an empty string so that nobody is able to exercise the freeze power anymore. Clawback address. This is the address of the account that has the power to move this ARSA from any owner's account to another one. This is given to ARSAs that require the possibility, for example, to revoke the asset in case of fraud. The clawback address can be replaced with an empty string so that nobody is able to exercise the clawback power anymore. As long as freeze and clawback addresses are not empty, there exists someone in the world who can eventually prevent you from transacting this ARSA or revoke it. You should be cautious. Once these addresses are replaced with empty strings, the process is irreversible, nobody can change them anymore. Asset config transaction. Since no one should be able to revoke Panzerato or Coccinha from their owners or prevent someone from transacting with these ARSAs, we will eliminate this possibility setting by updating the clawback and freezer addresses to an empty string. We want this to be clear, so we will declare our will through a note in the asset configuration transaction. We can now write down the whole asset configuration transaction in the command line and push it to the blockchain. I have written only for Panzerato. Go ahead and write for Coccinha using same example. Type it in the command line and enter to push the asset configuration transaction to the mainnet. Once the block containing the configuration transaction of the ARSA has been added to the blockchain, the asset management has been shaped, returning the configuration transaction ID. You can find the configuration transaction on a block explorer. Awesome. Our ARSA management is now fully configured. Remember that you still have the possibility to change the manager address or the reserve address. To learn more, visit the developers section. developer.algorand.org